Good morning guys, Anjani Kumar here, dealing power system 2 for third year electrical students. Right, in the last session we discussed about different types of insulators, right? I'll give a brief thing about what we did till now. So we discussed about what is an insulator, right? So what is the insulator? Insulator is a device which doesn't allow the leakage current from the conductor to the support and to the earth. If it allows, definitely if any person touches the support, the person will get a severe electrical shock. So that's why we need to provide insulation between the conductor and the supporters. So that is the concept of insulators that we discussed. What are the properties of insulators, right? So what are the properties of insulators means, which is having the high dielectric strength, right? And non-porous materials, there is no cracks, free from impurities, a temperature coefficient. So all these things are high mechanical strength, very very important property, high mechanical strength to withstand any type of load, right? That we discussed. So after that we started different types of insulators, right? So different types of insulators, right? So in order to estimate the successful operation of a transmission system depends on what type of insulators that you are choosing, right? On that basis, the insulators are categorized into 4 types that we discussed in detail, no doubt about that. One is a pin type insulator, and second one is suspension type insulators, and the third one is strain insulator, and the fourth one is Schottl insulator, right? So these are the 4 type of insulators, right? I'll give a brief glimpse about these type of insulators, right? So what is a pin type insulator, right? The pin type insulator that can be used for the voltage less than 33 kV, like a distribution system. In a distribution system, you are using these type of pin type insulators, right? All the insulators are made up of porcelain, right? Definitely there are some other materials also there, but we are not using nowadays. Only porcelain materials we are using for the manufacturing of these insulators. Why? Because the temperature coefficient it will be a much more factor affecting the design of insulators, right? So if a temperature increases, then the porcelain material won't melt. Like any other material, definitely they will melt with increasing the temperature, right? In a pin type insulator, which is having, I've already explained with neat sketches, right? Which is having a porcelain layer, right? The porcelain layers on the top of this. We are having a groove where the conductor is going to be melted, right? So from that, the conductor is going to be twisted over there, right? So beyond greater than 33 kV, we are not use these type of pin type insulator. Why? Because these are more economical, right? So there is a chance of failures occurs in a pin type insulator. There are 2 types of failures. So what are that? Flashover, and second one is a puncture, right? What is a flashover? Flashover means each and every layer must be designed like a glazing, nothing but it's a smooth surface. We are providing those porcelain layers are made up of a smooth layer. So if you provide like a rough layer, definitely whatever the dust particle will be stay there for a long time, and through the dust there will be a conduction will takes place. So at that point, the current from the conductor and it will flow through the dust particle and enter into the cross arm, and it will enter into the pole. So definitely when a person touches the pole, definitely will get severe electric shock. So this is one of this phenomenon we can call it as a flashover. I explained with neat sketches, right? So what is a puncture? Puncture means while erecting. So this is a groove now. These are the porcelain layers, right? మీరు ఎప్పుడైతే గ్రూను లోపలికి ఇన్సర్ట్ చేస్తున్నారో there will be a cracks will be there in a manufacturing defects, right? There will be a cracks. So with that cracks, my insulator will get damaged and the current from the groove, it will enter into the cross arm and it will enter into the pole. Definitely there will be a severe electric shock when person touches that pole. So this phenomena we can call it as a puncture. So we need to, when designing an insulator, we need to take care of these phenomena like flashover and puncture. We need to take care of safety factor. So what is the definition of a safety factor? Puncture by flashover. I think I explained with reverse, right? I just change that. So safety factor is defined as a puncture by flashover. So in a pin type insulator, so what is the safety factor? Safety factor we can take it as a 10. So this is about a pin type insulators, and after that we discussed about suspension type insulators. So what is a suspension type insulator? The name itself, suspension means suspended, right? Suspended, that means veladadiyadamu. So these type of insulator that can be used for greater than 33 kV. So that's why, right, that's why we can call it as a transmission line. In these type of insulators that we can use in a transmission system. Alright, so in this type of insulator we are having number of discs, right? Each and every disc is designed for 11 kV. If the conductor which is having a 66 kV, we are placing 6 number of discs parallel. Alright, so here on the bottom of this insulator we are providing the conductor where the current is going to be taken. Right, the conductor will be placed on the bottom and top, which is connected to the cross arm, and this is the pole. So in this step we are providing these suspension type insulators, right? What are the advantages? Means if any disc failure, no need to transfer, right? We just remove that disc and enter another disc over there. So no need to transplant all the disc, right? If number load on the conductor is increases, right? Suppose if it is a 33 kV, I am increasing the current as 66 kV. So what you should do, you directly add 3 more discs that it. So then definitely the insulator will be used for that 66 kV line. So this is one of the most advantages. And one more advantage is the conductor under this final disc, right? It will be freely moving, right? It doesn't have any mechanical stresses on this. So the chances of occurrence of faults are very less in this type of suspension type insulators, right? And what is a strain insulator? Right, the name strain is nothing but tension. Definitely in dead end or river crossings or height places, right, definitely there will be a tension on the conductor. In that situation we are using these strain type insulators, right? So you can use anywhere, right? Like from less than 11 kV to higher voltages also you can use these type of strain insulator, right? Less than 11 kV, these type of insulators we can call it as a Schottky insulator, right? One more concept is the Schottky insulator. Less than 11 kV, the strain type insulators we can call it as a Schottky insulator, right? And these type of insulator that can be used for high voltage also by making vertical places, right? So if horizontal places we place this insulator, we can call it as a suspension type insulator. In a vertical line we can place these type of insulators, we can call it as a strain insulator. If a conductor's tension is even more, you have to connect another parallel. So you have to connect like this. So this type of insulator we can call it as a strain insulator, right? Oh, these are the things that we, and one more type is a Schottky type insulator. Schottky type insulator means it is used for less than 11 kV. Like it's used in a distribution system. Like it is a pole mounted. So pole ki direct ga fix chestam. Here will get the insulator, right? The conductor is going to be taken out from this. We can see your street distribution system, all these things. Right? These are the different types of insulators that we discussed till now. Now I'm going to take. Now in this session we are going to deal about the important concept. So like in insulator, so that what we are going to discuss from this session is very, very important for your gate IES point of view. definitely you will get a question from this concept. So I hope each and every student should follow these videos from this session. It will be very helpful for your future also. Right? Now we are going to discuss about the suspension type insulators, so which are more used for a transmission system. Strain insulator is nothing but a suspension insulator, but the insulators that we are placing like a vertically. If it is a horizontally, we can call it as a suspension type insulator. If it is a vertically, we can call it as a horizontally, we can call it as a suspension type insulator. If it is a vertically, we can call it as a strain insulator. So that is a difference. So now the voltage, the main important concept that we are going to discuss here, potential distribution or suspension type insulator. Suspension type insulator strain. So this is very, very important. Now in a suspension type insulator, so what happened? This is used for greater than 33 kV. That means that can be used for transmission system, which is having number of porcelain discs which are connected in series, right? In horizontal, right? But suppose if it is a cross arm, so this is a metal conductor. Metal conductor. This is an insulator and another metal conductor. This is one more porcelain disc. Right. So you can fit your conductor like this. So this is a suspension type insulator which is having how many discs? 1, 2, 3. Total number of discs are 3. So it can be used for 33 kV. So from seeing itself, you can know how much current carrying of that conductor. So you can easily say there are 3 number of discs is there. So there might be a 33 kV line is passing through this. Right? This is a metal conductor, and this is a metal conductor, and this is a dielectric medium. So we can expect there will be a capacitance existence now. So I hope it's clear. This is a metal conductor. This is a metal conductor. And this is a metal conductor. Right? This is a dielectric medium. So there will be a capacitance exist now. Capacitance means two metal conductor between there is a dielectric field. So that will forms the capacitance. So how you can take this one? So I can replace this one as. So this is a metal conductor and a capacitance will be exist, and the capacitance will be exist, and capacitance will be exist. Right? So this is a disc 1 capacitance, disc 2 capacitance, disc 3 capacitance. So if the capacitance existence that means there will be a voltage will be developed across the capacitance now. So what is that voltage? So we can expect the voltage from here is V1. Here is V2. From here is V3. Right? So this is the conductor where you are taking your conductor. Right? If this capacitance existence means if only this capacitance is present in the system, so whatever the current that flowing across this suspension will be the same now. Only this capacitance is exist, no other capacitance. This is a self capacitance, this is a mutual capacitance. Only one capacitance existence in this suspension type insulator. The current is equal now, because these are the series, right? The current is equal now, so the same current will flow. So if the same current will flow means whatever the voltages between these three capacitance will be equal now. So whatever the voltage, V1 is equal to V2 is equal to V3. So up to now there is no problem for the suspension type insulator, right? Each and every disc you are getting a similar voltages. So at this point we don't have any tension, you don't have any stress on this suspension type insulator. Now this is the ideal thing. So you won't expect only one capacitance will be exist in the system. So thereby the current is equal. So thereby the voltage is equal across the every string. But there will be a tower now. We'll see. You will see here. This is a cross arm now, right? From this cross arm you have a tower now. This is a tower. This is a tower. Now here the capacitance is existing. Here one more capacitance is existing. One more capacitance is existing. And this is your conductor, right? See, this is a metal conductor and this is a pole. So between these two there will be a chance of capacitance na. This is a conductor na, the current carrying conductor. So this is a conductor and this is a supporter. That means steel supporter. So there must be a chance of capacitance exist between these two na. So what is that capacitance? So we can call it as a shunt capacitance. Right? There are how many shunt capacitance? 3 shunt capacitance. So this we can call it as a self capacitance. C. So this we can call it as a shunt capacitance. C1, C2. So with the effect of the shunt capacitance, my current flowing through the entire suspension type insulator, that is not equal current. So the current is distributed. Like if this current is, if it is I1, I2, this is I1, and some current will flow through this like this, and this is I3. So whatever this I2, and this is I2, and this is I3. So likewise this, the current is changing. If the current is changing, whatever the voltage across the capacitors also changing now. So V1, V2, V3, right? All these capacitance voltages are different. That means V1 not equal to V2 not equal to V3. So under this condition, you will definitely clearly that the conductor, so here is a conductor, the capacitor which is the disc which is nearer to the conductor, which is having high voltages, which is having high stress on voltages, right? So let me explain one more time. So when a disc which is nearer to the conductor itself, which is having maximum stress and goes on, your voltages are decreasing, right? So the conductor which is nearer to the disc, which is having high stress, means very, very capable of puncture. So there is a high risk of puncture at this disc. So definitely what happened? Total suspension string will get damaged. I hope it's clear, right? If it is same current flow through these all capacitance, there is no chance of maximum stress. All the discs are equal potentials, right? When a shunt capacitance existence between the metal conductor and the supporters, so there will be a current will be vary na. If the current is varies, means each and every disc దగ్గర voltages వేరీగా ఉంటాయా. సో ఎక్కడ voltage maximum ఉంటుంది? కండక్టర్ కి దగ్గరలో ఉన్న డిస్క్ యొక్క voltages maximum గా ఉంటుంది. So definitely what happened? Whenever the maximum stress on the conductor, first ఈ డిస్క్ డ్యామేజ్ అయిపోతుంది. సో ఈ డిస్క్ డ్యామేజ్, కండక్టర్ క్యారింగ్ డిస్క్ ఇదే కదా, ఈ డిస్క్ డ్యామేజ్ అయింది అనుకో, డెఫినెట్లీ ద టోటల్ సస్పెన్షన్ స్ట్రింగ్ విల్ గెట్ డ్యామేజ్. సో వాట్ ద పాయింట్స్ దట్ వీ నోటెడ్ ఫ్రమ్ హియర్, డ్యూ టు ద షంట్ కెపాసిటెన్స్ the voltages across the strings are varies, right? So which one is maximum? The conductor, the disc which is nearer to the conductor, which is having a maximum stress. So that is another point, right? Due to this voltage variations, the maximum stress across near the conductor disc will get damaged first. So if it is damaged, total suspension will get damaged. So this is about what I am saying. So it is our aim to make all these voltages across the string. That means across every disk must be equal. So what is the point that I have noted down the point. I hope it's clear. One more time I'll explain one more time. Listen. So why the concept is means the potential distribution over a suspension insulator. So what is that thing means? A transmission system, the insulator that we are placing in a transmission system, so we need to take in care, because the high current that can be flows through a transmission system. So pin type insulator that is used for a distribution system, there is a chance of flashover and puncture. So we can protect that from the safety factor itself. But what about the suspension type insulators that are used in a transmission system? So how you can save that one? Per suppose there are 3 disks, that means 33 kV transmission system that you are using. So each and every disk means there is a metal conductor. Between this you are placing a dielectric medium, so it will forms the capacitance, right? So this only capacitance will exist, so only C will exist. So the current is equal, and whatever the voltages across each and every disk is equal. So if these all voltages equal, there is a no problem across the suspension type insulators, right? There will be a no problem. If it is a problem occur, definitely we need to replace, or we need to change the disk value. That's it. And in practical, so only that capacitance will not exist. So there will be chances of shunt capacitance. So between the conductor, between the suspension string and the supporters. So that capacitance we can call it as a shunt capacitance. Due to the shunt capacitance, the current in the suspension, current in the string, which is not equal. So the current is varying here. So the current from here, it will transfer here. So the current will change. This current, some current will flow here, some current flow here. This current, some current flow here, and some current flow here. Due to this, each and every disk, the current is varying. If the current is varies, means whatever the voltages across the disk is varying. So if the voltages across the disk is varying, means which disk which is having a maximum stress, means the disk which is nearer to the conductor which is having a maximum stress. So there is a high risk of failures from first disk itself. So if it is failure, total string will get damaged. Right? So that's our aim, to make each and every disk voltages must be equal. So how you can make this one? So that's the concept of string efficiency. So we need to maintain the string efficiency in a suspension type insulators to make each and every disk voltages are equal. So that's why we need to maintain the string efficiency. So I'll note it down. What are the points that we got till now? So first point, the voltages of total string not uniformly distributed, right? Total string not uniformly distributed, right? So when the maximum voltage that we get at near the conductor disk. So near the conductor disk which is having a maximum stress. So the maximum voltage that appears. So the chances of punctures that occurs at near the conductor disk. So the chances of a puncture that can be occur near the conductor disk. So these are the points that we'll get from the suspension type insulator. How we should avoid, how we should make all the disks equal potential, all the disks uniformly distributed. How you can make. So that can be described with the help of string efficiency. So we need to take care of a string efficiency with in this type of suspension insulator in order to provide these unequal voltage distributions. Right? So this is about this session. In the next session, We are going to discuss about what is a string efficiency, what is a formula for string efficiency, all these things that we discussed in the next session. Thank you for now.